Part 1. The journey begins. Imagine for a moment a starry night, a time long before telescopes, or even the first whispers of science. The night sky stretches endlessly above, and there, cutting through the darkness, is the Milky Way, an ethereal glowing ribbon of light. For centuries, it captivated the human imagination. But what was it? What was this band of light, and how did it come to be? Let's embark on a journey through time as we explore the history of the Milky Way. A story that begins with myth and moves through centuries of discovery, revealing one of the greatest cosmic mysteries ever to be solved. Chapter 1. The Ancient View. Our story begins in the distant past, long before the tools of science were even dreamed of. To the ancients, the night sky was more than just a collection of stars. It was a canvas of stories, mysteries, and divine wonders. In ancient Greece, the Milky Way was believed to be the milk spilled by the goddess Hera as she nursed Heracles, creating a celestial river across the heavens. The Greeks called it the Galaxius Kyklos, meaning milky circle. To them, it was a divine and mysterious mark on the sky, one that was both beautiful and unexplained. But the Greeks weren't the only ones to weave stories about the Milky Way. In Native American cultures, particularly the Hopi people, it was seen as a pathway for the dead, a way for souls to journey between this world and the next. The ancient Chinese, too, called it the Silver River, a way to describe the path of a star-crossed couple, separated by the gods but able to reunite once a year across the sky. And while these myths were rich in meaning, they didn't give us the answer to their old question: what was the Milky Way? Chapter 2. The Dawn of Science. It wasn't until the 17th century that humankind began to take a step away from myth and into the realm of science. Enter Galileo Galilei, a man whose curiosity and telescopic vision would forever change the way we saw the stars. In 1609, Galileo turned his newly perfected telescope toward the night sky. For the first time, he saw the Milky Way in a way no one ever had before. What appeared to be a faint, cloudy band of light was, in reality, a vast collection of individual stars spread out over vast distances. Instead of one hazy glow, Galileo realized that the Milky Way was composed of countless stars, each one distinct and separate from the other. This discovery was groundbreaking. It showed that the Milky Way wasn't a solid, divine object in the sky. It was a galaxy, just like any other, filled with stars and cosmic wonder. But despite this revelation, the full nature of the Milky Way remained elusive. Galileo had opened a door, but it would take more than just a look through a telescope to understand the true size and shape of the galaxy. Chapter 3. Mapping the Stars. In the 18th century, astronomers began to take a more serious approach to mapping the stars and figuring out the structure of our galaxy. One of the most important figures of this time was William Herschel, the German-born British astronomer known for his discovery of the planet Uranus. In the late 1700s, Herschel turned his attention to the Milky Way. He believed that by counting stars in different parts of the sky, he could map the shape of the galaxy. He also believed, based on his observations, that the sun was at the very center of the Milky Way, surrounded by a dense cluster of stars. Herschel's work was revolutionary in many ways, and his mapping of the Milky Way provided a nearly glimpse into the vast scale of the galaxy. But like Galileo before him, Herschel's model was not entirely accurate. The idea that the sun was at the center of the Milky Way was soon challenged. But Herschel's pioneering work set the stage for the astronomical breakthroughs to come. Chapter 4. The 20th Century Revolution. Wasn't until the early 20th century that astronomers made a series of discoveries that would redefine our understanding of the Milky Way. By now, the telescope had become a powerful tool, and the universe was becoming more and more accessible to scientific exploration. In 1917, astronomer Harlow Shapley made a groundbreaking discovery that would shake the scientific community. By studying the distribution of globular clusters, dense spherical collections of stars, Shapley was able to determine that the sun was not at the center of the Milky Way, as Herschel had believed. Instead, the sun was located far out on the edge of the galaxy, some 30,000 light years from the center. Shapley's work gave us a new understanding of our position in the galaxy, and for the first time, we realized how small and insignificant our solar system was within the vast expanse of the Milky Way. But there was still so much more to learn. Chapter 5: The Expanding Universe. The 1920s marked another monumental leap in our understanding of the universe. A young astronomer named Edwin Hubble, working at the Mount Wilson Observatory in California, made an extraordinary discovery that would forever change the way we looked at the cosmos. By studying distant nebulae, clouds of gas and dust in space, Hubble determined that some of these nebulae were, in fact, entire galaxies far beyond our own Milky Way. This discovery proved that the universe was far larger than anyone had previously imagined. The Milky Way was no longer seen as the center of the universe. It was just one of billions of galaxies, each with its own stars and mysteries. But Hubble didn't stop there. He also discovered that galaxies were moving away from each other, and the farther a galaxy was, the faster it seemed to be receding. This observation laid the groundwork for the discovery of the expansion of the universe, a revelation that would lead to the formulation of the Big Bang Theory. Chapter 6: Unraveling the Structure. Throughout the 20th century, astronomers continued to study the structure of the Milky Way. In the 1940s, John Oort, a Dutch astronomer, made significant progress in mapping the galaxy's rotation. He realized that the Milky Way was not a simple static system, but a vast rotating disk. The stars were moving in a coordinated manner, swirling around the galactic center like planets orbiting a star. This was the first clear indication that the Milky Way was a spiral galaxy, a vast, flat disk of stars, gas, and dust with a bulging center and sweeping arms. But the mystery was far from over. Chapter 7: The Galactic Core. In the 1990s, astronomers made a discovery that would add yet another layer of complexity to the Milky Way: the existence of a supermassive black hole at the center of our galaxy, Phrygia. For years, astronomers had observed strange behavior near the galactic core, where stars seemed to be moving erratically. Using advanced radio telescopes, scientists tracked the orbits of these stars and concluded that they were being influenced by a massive invisible object. It was then that they realized the center of the Milky Way contained a supermassive black hole with a mass equivalent to millions of suns. This discovery not only changed our understanding of the Milky Way, but also of how galaxies evolve. Black holes, once thought to be theoretical, were now known to be central to the workings of galaxies, powerful cosmic engines that could shape the future of the entire galaxy. Chapter 8: Our Place in the Universe. In recent years, astronomers have come to realize that the Milky Way is just one galaxy in an infinite expanse of cosmic wonder. There are billions of other galaxies, each with its own stars, planets, and black holes. And yet, our galaxy remains a unique and special place. It is the home of Earth, of humanity, and of all the life we know. The Milky Way is not just a beautiful band of stars in the night sky. It is a dynamic, ever-changing system, filled with mysteries yet to be discovered. As we look to the future, we know that the Milky Way holds more secrets, more discoveries, and more lessons about the universe and our place within it. Chapter 9: The Future of the Milky Way. In about 4.5 billion years, our galaxy will face a cataclysmic event, a collision with the Andromeda Galaxy. The two galaxies will spiral toward each other, their stars slowly merging, their gas clouds interacting, and eventually forming a new galaxy. But don't worry, this collision won't be as dangerous as it sounds. The stars in each galaxy are so far apart that they're unlikely to collide directly. Instead, the two galaxies will become a new, larger galaxy, a cosmic merger of two worlds. As the Milky Way and Andromeda merge, it will be a new chapter in the life of our galaxy. One that will reshape the stars, the planets, and perhaps even the very nature of the galaxy itself. But that's a story for another time, millions of years from now. Conclusion of Part 1. A never-ending journey. The history of the Milky Way is astery still being written. From ancient myths to modern science, from simple observations to complex theories, we've come a long way in understanding the galaxy that is our home. But the journey is far from over. As technology advances and our understanding of the universe deepens, we will continue to learn more about the Milky Way, uncovering secrets that have been hidden for millennia. The Milky Way, in all its mystery, remains a symbol of human curiosity and the boundless possibilities of exploration. And so the story of the Milky Way continues, not just in the past, but in the future. And perhaps one day you'll look up at that same band of stars and wonder, what mysteries will we uncover next? Part 2. Are we alone? The universe, vast and unfathomably old, has always sparked one central question in the hearts and minds of humankind. Are we alone? When we look up at the Milky Way, stretching across the night sky like a cosmic river, we are drawn into the mystery of whether we are just one tiny speck of life in a galaxy teeming with others, or if we are indeed unique in all of the infinite stars and planets. The question of extraterrestrial life has captivated humanity for centuries, but it's only within the past few decades that science has begun to make significant strides in answering it. As we peer deeper into the cosmos, one thing becomes increasingly clear. The Milky Way, with its hundreds of billions of stars and possibly trillions of planets, could very well harbor the conditions for life far beyond Earth. So how likely is it that life exists in our galaxy? And if it does, what might that life look like? Chapter 1. The birth of the question. It wasn't always so. For much of human history, the idea that Earth might not be the only cradle of life was considered absurd. The ancient Greeks and Romans thought of the cosmos as a finely ordered place, with Earth at its center, uniquely suited for life. The heavens were seen as distant and uninhabitable. But in the 16th and 17th centuries, ace-early astronomers like Copernicus and Galileo challenged the Earth-centered view of the universe. Our place in the cosmos began to seem less unique. Galileo's discovery of moons orbiting Jupiter and Kepler's laws of planetary motion hinted that there might be other worlds, other Earths out there. Yet, it wasn't until the 20th century that the idea of alien life took a more scientific turn. In 1961, astronomer Frank Drake formulated the Drake equation, a groundbreaking attempt to quantify the likelihood of intelligent extraterrestrial civilizations in our galaxy. The equation combined factors like the rate of star formation, the fraction of those stars that have planets, and the probability of life developing on those planets. It was, and still is, one of the most important frameworks for considering the possibility of life beyond Earth. Chapter 2. The Habitable Zone and Exoplanets. With the dawn of the space age, the question of alien life moved from speculation to scientific investigation. The late 20th century, the search for exoplanets, planets that orbit stars other than our sun, began in earnest. By the early 2000s, astronomers discovered the first Earth-like exoplanets, raising the exciting possibility that there were planets out there that might harbor life. But the discovery of these planets wasn't enough. Scientists needed to understand whether those planets were truly capable of supporting life. To do so, they focused on the concept of the habitable zone, also known as the Goldilocks zone. This is the region around a star where the conditions are just right for liquid water to exist, essential for life as we know it. Too close to the star, and water would evaporate. Too far, and water would freeze. Earth resides in our sun's habitable zone, and it's the key to understanding whether life could exist on other planets. In the decades since, we've discovered thousands of exoplanets, many of which sit in their star's habitable zones. For instance, the discovery of Kepler 452b often called Earth's cousin in 2015, ignited fresh excitement. This planet, located 1,400 light-years away, was found orbiting a star similar to our Sun in the habitable zone, making it a prime candidate for potential life. But habitable zones alone don't guarantee life. As we've learned from Earth's extreme environments, life can thrive in places we once thought inhospitable. Deep-sea hydrothermal vents, acidic hot springs, and even under the frozen surface of Antarctic lakes. This broadens the search for alien life beyond just Earth-like conditions. Chapter 3: Extremophiles and the Possibility of Life. Elsewhere, one of the most profound discoveries in the search for extraterrestrial life came not from other worlds, but from our own. The discovery of extremophiles, organisms that thrive in conditions once thought impossible for life. From bacteria living in boiling acid pools to organisms that can survive without sunlight, extremophiles have shown us that life can adapt to an incredible range of environments. This suggests that life elsewhere in the Milky Way could exist in forms vastly different from anything we are familiar with. For example, some scientists speculate that on icy moons like Europa, one of Jupiter's moons, or Enceladus, one of Saturn's moons, liquid water may exist beneath thick layers of ice. Hydrothermal vents on these moons could provide the necessary energy for microbial life to survive. Life that is radically different from what we know, but life nonetheless. Moreover, the discovery of organic molecules in comets, asteroids, and interstellar dust suggests that the building blocks of life are widespread throughout the galaxy. The question is no longer, is life possible? But where is it hiding? Chapter 4: The Fermi Paradox. But even as we uncover more and more potential habitable worlds, one question persists. Where is everyone? This is known as the Fermi Paradox, the apparent contradiction between the high probability of extraterrestrial civilizations existing in the Milky Way and the lack of evidence or contact with them. With over 100 billion stars in the Milky Way, each with potentially dozens of planets, why haven't we encountered any alien civilizations? Several possible explanations have been proposed. Rare Earth hypothesis. Perhaps Earth is incredibly rare, and the specific conditions required for intelligent life are so improbable that we are an exception. Great filter. It's possible that most civilizations fail to survive long enough to communicate with others, either through self-destruction or catastrophic events. The filter could be something that prevents most civilizations from reaching the level of technological advancement necessary for interstellar communication. Another possibility is that extraterrestrial life is already here, but we are simply unable to detect it. Perhaps alien civilizations are using communication technologies we haven't yet discovered, or they have chosen to remain undetected. It's also possible that we are simply looking for the wrong signs. Search for extraterrestrial intelligence. Efforts primarily search for radio signals from advanced civilizations. But alien life might be so different from us that we can't yet recognize their signals or their form of existence. Chapter 5: The Search for Extraterrestrial Intelligence, CT. Since the 1960s, scientists have launched various efforts to search for intelligent extraterrestrial civilizations. The most famous of these is the Search for Extraterrestrial Intelligence, SETI, which listens for radio signals or other communications from distant stars. SETI researchers have scanned vast regions of seeking repeating patterns or signs of intelligent design, but so far they have found nothing definitive. Despite this, many researchers remain hopeful. They argue that the odds of detecting a signal are slim, considering the vastness of space and the many challenges of communication across light years. Yet even if we don't hear from alien civilizations through radio signals, scientists are beginning to think beyond traditional SETI. Techno-signatures, evidence of advanced technological activities, could be another key to finding alien life. This could include artificial lights on distant planets, megastructures like Dyson spheres, or even pollution in the atmosphere of exoplanets. In this new era of exploration, detecting signs of alien technology is just as important as listening for signals. Chapter 6: The Great Galactic Silence. Perhaps one of the most profound aspects of the search for alien life is the great galactic silence, the eerie quiet that we experience in our galaxy, despite the overwhelming possibility of alien civilizations existing. This silence leaves us with one of the most profound questions in science. What does it mean if we are truly alone? As humans, we have always looked outward, hoping that the stars would provide answers. But what if the search reveals that life in the Milky Way is as rare as it seems? The silence would challenge us to reconsider our place in the universe, not just as inhabitants of Earth, but as an isolated species in a vast, empty galaxy. But even in this silence, hope remains. With each new discovery, each new exoplanet, each new clue about life's adaptability, the possibility that we are not alone becomes a little more tangible. Chapter 7. The Future of the Search. So what lies ahead? The search for alien life is far from over. In fact, we are only at the very beginning of this cosmic journey. Telescopes like James Webb and future missions to the moons of Jupiter and Saturn will continue to expand our understanding of where and how life might exist beyond Earth. As we explore more exoplanets, map the atmospheres of distant worlds, and look for signs of alien technologies, we move closer to answering the age-old question, are we alone in the Milky Way? Conclusion of Part 2. Not alone after all. The possibilities are endless. From microbial life hidden beneath the ice of distant moons to advanced civilizations spread across the stars, the Milky Way holds the potential for life in all its forms. While we may not have definitive answers yet, the quest for alien life is one of humanity's most profound journeys. A journey that will define our understanding of the universe, our place in it, and the infinite possibilities that await us. The search continues, and as we venture into the unknown, we may one day look up at the Milky Way and realize that we're not alone after all.